Everyone knows that without microchips, modern civilization would instantly collapse into the dark ages. From the RAM speed boosting your PC to the processors driving your smartphone, advanced weapons, and AI supercomputers, these microscopic silicone brains run our entire world. But the mind-blowing truth is that making a chip isn't just an engineering miracle. It's the most high-stakes, dangerous geopolitical war on Earth, involving sand, laser physics, TSMC, and top-secret trade bans between global superpowers. To understand how a chip is actually born, you have to look at the microscopic assembly line. It all starts with basic sand, refined into pure silicone and grown into a massive single crystal ingot. This ingot is sliced paper thin into shiny discs called wafers, which are polished until they become atomic level mirrors. Next comes photolithography, the absolute pinnacle of human technology. A wafer is coated with light-sensitive chemicals, and a multi-$100 million machine uses extreme ultraviolet lasers to etch blueprints onto the silicon. We aren't drawing lines here. We are packing over 100 billion microscopic transistors onto a surface the size of a fingernail. After that, high-energy plasma implants specific atoms into the silicon to create conductive pathways, layering ultra-thin gold, copper, and aluminum connections into a 3D microscopic skyscraper. Once the wafer is complete, it is cut with precision laser saws into individual dies, the raw silicon chips. But a naked silicon die is fragile and useless on its own. It needs to be packaged, and this is where the global supply chain gets wild. While the most advanced logic chips and memory dies are designed in the United States and etched in Taiwan or South Korea, the crucial next step, advanced packaging and testing, is heavily outsourced to Southeast Asian hubs like Thailand, Malaysia, and Vietnam. In high-tech facilities across Thailand, raw silicon dies are encapsulated in heat-resistant black ceramic or plastic housings, wired with gold pins, and soldered onto DIN fiberglass circuit boards to become the final RAM sticks or processor units you can actually hold in your hand. Because these chips control everything, from consumer electronics to hypersonic missiles and advanced artificial intelligence, they are at the center of a brutal technological war between the United States and China. To maintain military and economic dominance, the U.S. government implemented strict, sweeping export controls and trade bans. Under these agreements, major manufacturing nations and global semiconductor giants are strictly forbidden from selling cutting-edge chips, advanced manufacturing equipment, or high-performance AI processors to China. If a company or a country like Thailand or Taiwan violates these U.S. trade restrictions, they face devastating sanctions and could be completely cut off from American technology and financial systems. That is why high-tech factories in Thailand operate under tight geopolitical surveillance to ensure that the microscopic silicon driving the world's highest intelligence stays strictly out of enemy hands. The ultimate, mind-blowing truth is that a modern chip is far more than just melted sand and clever circuitry. It is the most complex physical object humanity has ever built. A microscopic battleground where physics, global trade, and superpower politics collide on a surface smaller than a postage stamp.